Thank you very much for being here today. Excited to share with you. So, like was mentioned, I'm Tristan McKinnon. I'm the actually now the lead. Oh yeah, they improved my title, the lead healthcare data engineer at Axel Informatics, and I'm also the principal investigator for a private research laboratory, deterministic systems. Yep, there we go. Cool, everything's good. Yeah, so working on the research behind what I'm going to share with you today. So yeah, let me go ahead and jump on in here. Yeah, like the background said there, working in deterministic systems lab, and then also Axel Informatics. And then the architecture that I'm presenting today was actually also published a couple weeks ago at the IEEE Big Data Security conference. Yeah, that's the word. You can find the preprint for that on Tech Archive if you're really curious about like deep diving into the threat models and evaluation, but I'm going to cover the good stuff today, so don't worry about that. So looking at this here, a quick show of hands. How many of you have a service account in production that could access the bulk or entirety of your database? Seems about right. And how many of you can say with complete certainty that you know what every service account actually does, or when it was used last? Okay, I'm impressed. That's actually more than I usually find, because the problem that keeps me awake at night, and I'm guessing a number of you as well, is that most enterprise data pipelines authenticate with a service account. So that's one IAM role, one set of credentials, and that role can read pretty much every object in the data lake. So if an attacker compromises it, and let's be honest with the current environment and enough time, it will be compromised. They own everything. So how long do you have? Industry best practice, you're rotating your keys every 90 days. So, if you are being a best practice person, you're looking at, 89, 90 days of access where they could exfiltrate everything. I mean, that's not a security model, that's a countdown. So what we did here with the identity per transaction format is we flip this. Instead of one credential for the whole lake, we have every file that enters the pipeline getting its own credential. So that credential can touch the one file. It lives for up to 900 seconds because it was built off of AWS STS, and then it expires. So that credential gets the one file, does its job, and it's gone. So if an attacker intercepts it, they get one file. Congratulations. And then the credential self-destructs. So that's the shift that we're looking at here. So we built this and validated it in a pattern for the hardest environment you can really have for regulation, FedRAMP High. And if you aren't familiar with it, it's a the U.S. federal government's strictest cloud security baseline. It's 421 controls. It covers systems where the breach would cause severe or catastrophic harms. We're looking like genomic data, veteran data, looking at healthcare records, clinical trials. But I want to be clear about something with this. These patterns work for anywhere that handles sensitive data. FedRAMP, PCI DSS, if you're looking at SOC 2, GDPR, HIPAA, or if you just like the idea of not getting breached. I mean, so I built it in healthcare. Yeah, I mean, it's true. I built this in healthcare, but the idea was it's translatable. And the architecture is kind of a key part of this. So 3 zones, looking at data flowing from left to right, and it never goes backwards. I mean, that's an important part. It sounds silly, but it needs to be said directly. So starting off, we have the dirty zone, and that's an encrypted S3 bucket. Data lands there with zero trust. Producers can write to it. Like in my case, I use Airbyte for the writing because I want to hard code every relationship from source to my bucket. So Airbyte can write to it, but nobody can read from it. Not analysts, not dashboards, not data science team. I can't read my own bucket. It's walled off. Then the airlock is where that processing happens. So it's an isolated VPC with no internet gateway. Ephemeral Lambda or Glue functions will boot up inside of there, process the file, and die. They communicate with AWS services exclusively through their VPC endpoints. There's no path to the public internet from inside the zone, so if you ever spent time 3 hours or so debugging why your Lambda couldn't reach the internet, congratulations, that's a security feature. Yeah, and so then after that point, you have the clean zone, and that's the destination. By the time the data arrives there, you've de-identified it, schema validated, governed. It's cleaned up and it's ready for your analysts. But sitting below this airlock is the important part, and that's the identity broker. And so what that is when the file lands in the dirty zone, the broker provisions a scoped credential just in time and lets the airlock function touch only that specific file. So that's the identity per transaction pattern. So let's jump in here with the identity broker. So let me show you the code. I packaged this pattern into an open source library called PyMayfly. I can speak, I swear. So you can install it right now if you want to. We'll wait like 45 minutes. I was doing some smoke testing and I wanted to kind of fix something before I actually did that, but I went to one too many of the open happy hours last night, so a little bit of delay. But the interface you create with the IPT enforcer as a broker. And in this case, we're using AWS STS because that's the model I built off of in the first place, but I have some extensions I'm working on right now for Hashimoto Vault to make it agnostic, as well as building in ones for Azure and GCP. So when you decorate your processing function using the enforcer protect, that decorator takes two arguments. The resource from is a lambda that extracts the S3 object ARN from the incoming event, and then action tells the broker what permissions to scope. Your function receives a credential, a creds keyword argument, and that's the scoped session that can only perform the specified action on the specified resource. Your function doesn't know or care how it got the credentials, it just uses them. But when the function exits, whether it succeeds or throws an exception, the credential reference is discarded and the destruction is logged. The credential itself expires at most after 900 seconds, and you can adjust that through some basic parameterization. But that's the entire interface, just 3 imports, 1 decorator, done. I want to show you what's actually happening under the hood, because it's not complicated, but it's important to see the machinery before you trust the abstraction. So what Mayfly saves you from writing every time, and if you enjoy writing that, I've got some Terraform code that we should really talk about because I don't know. But this is a raw STS call. First, we build an inline IAM policy. And if you look at the resource field, it's not a wildcard or a prefix. It's not a bucket. It's a single S3 object key. The ARN, AWS, one file. And then we call the STS assume role, and that's the one role ARN points to, the processing role, and that has the broad S3 permissions. But here, we pass the inline policy with that at assumed time. So AWS intersects the inline policy with the role's permissions, and even if the role allows S3 on everything, the resulting session can only get object on the one key. Like the inline policy is the ceiling, not the floor, is the idea here. And so it's highly restrictive in how it's constructed. The session name embeds a trace ID, mayfly dash, whatever the first 12 characters of the request ID. So every credential is traceable back to the exact invocation that created it. So for auditability, you have every activity. You can trace back to the creation. You can trace back to the permissions that were granted. You have complete transparency in how that's done. Like my logs look beautiful, I'm not gonna lie. It's my favorite part of this whole thing. And so the default duration, like I said, is 900 seconds, and there's some parameterization that I'm putting in so you can make that shorter if you want to. I personally like to keep it that way just because sometimes your Lambda function needs to go that full extent, and if 900 seconds hits, the whole process dies. So there's that element of constraint, but we'll kind of circle back to that. So the STS minimum, the Lambda maximum is the 900 seconds. In practice, our functions we're running between 30 and 90 seconds in length, but I did have some long running ones. But Mayfly handles the entire lifecycle, like the policy construction, the STS call, the session injection, the audit trail, and the cleanup. You just write the processing logic that happens within the function. And just to kind of review, here's the scope policy on its own, just so you can see it clearly. It gets passed to assume role as the policy parameter is one statement, one action, one resource. The session that comes back from STS can do exactly that one thing, which is just read this file. If the attacker compromises this credential mid-flight, intercepts it somehow, they can read access to the one file for at most 15 minutes. It's not the lake, it's not your bucket, it's just the one file. And the nice thing is I've actually, we did some pretty aggressive pen testing on this, and nothing got past that just because we're talking about construction level. STS does not have the ability to be changed. Those roles are immutable. And so with that, you have a very hard limit on the security. So the question that comes up, and I'm sure a couple of you are thinking about it right now, is, all right, so we're invoking an identity for every single object. Scaling up, that's got to eat up time. And, there's a hint of latency, I'm not going to lie. It's about 120 milliseconds for a warm STS call, and that was us using US West 2 for our stuff. And because it's a Lambda function that that uses the identity broker that then invokes the ID. The first time we ran it, it has about a 400 millisecond start time. But then it stays warm during the course of the session, so you have the 120 seconds. So, all told, like with the average object, we're looking at like 0.1% of overhead, because we're looking at, about a 500 megabyte file, actual transformation times a couple of minutes, 120 milliseconds, yeah, so it's like, 1/10 of a percent. And it's funny because we actually spent like 6 weeks arguing back and forth about whether STS latency was going to be an acceptable issue. We kind of came to the conclusion when we were looking at it that we'd spent more time arguing about this latency than we'll ever cumulatively acquire over the course of our entire lifetime of pipeline. So we're like, you know what? It's 1% overhead. Like it's noise. And that's kind of why I like the title of the talk, zero trust in 200 milliseconds, because it's not an aspirational goal. That's measured overhead. Like we keep identity instantiation. It's one of those words, man. Under 200 milliseconds, and it doesn't throttle the pipeline. So it worked nicely. Because just throwing this in here again, because I know the other thought process, we heavily parallelize with it. So we're not doing serial accumulations. We're doing parallel and staggered. So all right, so then another caveat with this is to make proper use of the error lock, like I mentioned earlier, doing the de-identification and processing in transit with the error lock. And the important aspect of it is doing it in stream. So the scope credentials control who can access the data. The de-identification controls what data it contains when it gets to the clean zone. So in my case, we used Microsoft Presidio just because it was an easy open source option, relatively lightweight. And the key part of it really, though, is the use of generators for the movement of the data itself. So we never load the full data set into memory because I don't want to create more records. I don't want more copies of it anywhere. I don't want it touching somewhere that someone else could touch. And so the record flows through the generator one at a time, analyzed by Presidio for PII entities. So like person names, SSNs, phone numbers, take your pick. And then it's checked against a confidence threshold. And then anything that's found is anonymized and then yielded downstream. So memory stays flat regardless of patch size. You could push 1 million records through this generator and it would use the same amount of RAM as pushing 10. And the confidence threshold I chose was 0.95. Anything below that, the record where Presidio isn't at least 95% confident that it found all the PII, gets quarantined instead of passed through. And I'll show you why in a moment. But the note at the bottom, by the way, just to clarify, is we're currently using Presidio, but we are evaluating running Spacey directly for the high throughput element of it. Presidio wraps Spacey under the hood for NER, but then it adds its own analyzer pipeline on top. And for paths where we've already profiled the entity types, calling Spacey directly would probably reduce the per record overhead a little bit. So we're working on that. Just wanted to throw the note in there because it's always good to think about. But the quarantine element here. So this slide is probably the most important architectural decision in the entire pipeline, despite being relatively simple. Sorry, I realize the color contrast is kind of intense on that blue. But the record comes in, Presidio analyzes it, and if the confidence is at or above 0.95, it goes to the clean zone. Below that point, though, it goes to the dead letter queue for human review. And we landed on 0.95 after tuning against the I2B2 2014 de-identification corpus, because at that threshold, the false negative rate drops below 2%. And we definitely want to keep that number low because the cost of getting it wrong is like wildly asymmetric. Because a false positive, a clean record that gets quarantined costs you 30 seconds of review, but a false negative, a record with PHI that leaks through, that's going to cost you a conversation with your CISO. And I don't know if any of you have ever had to do that, but I remember my last one, and nope. So when in doubt, quarantine. All right, and then the last part of this little flow here is the audit-ready logging, and that's the part I alluded to earlier. Because this is that paradox that you run into with any form of compliance. You have two federal agencies in my case, both absolutely certain about what should log, and they disagree completely. So if you've ever worked in the government contracting or anything like this is probably a familiar feeling to you. Because we have FedRAMP AU2 that says log every access event. You need to prove who touched, you need to prove what they touched, you need to prove when they touched it, then you need to know why they touched it. HIPAA, on the other hand, says don't log anything sensitive. So if you have your audit, if your audit trail contains patient names and SSNs, then you've just created a second attack surface. So both are federal requirements and both apply simultaneously, so you have to find a balance. The resolution I settled on was log the credential lifecycle, not the data. So that's kind of where the part of Mayfly's audit entry looks like here is, yes, the audit entry. The idea behind it is that we log that the credential was created, the session time for traceability, the resource ARN that was scoped to, and how long the STS call took. And then we have a canary hash in order to make sure that it's trustworthy within audits. So this is what the Mayfly audit entry looks like. We log that the credential, and then we never log what was in the file. We never log patient names, we never log SSNs, clinical data. We log who created the credential, for what resource, and then for how long. The canary hash we're using is SHA 256, and it's a log of the entire log record, so that if anyone modifies it after an entry, then it's pretty obvious that it was done. Because we can just do a simple comparison of the event log and then the canary hash, and we can see, oh, something was changed. Let's see. But in production, these logs ship to an S3 with an object lock in compliance mode, and so it's warm storage. Nobody can delete or overwrite a log entry, and root has no ability to do anything as well. So kind of putting all this together, because I know I ramble in sidebar here. The credential scope, traditional models will give you bucket-wide or worse, lake-wide access. The IPT is going to give you a single object. The blast radius, if something goes wrong in the traditional model, you're looking at, up to the entire lake, whereas with this, the hardest we ever found is one file. Compute lifespan, so a traditional cluster, run for days or years, especially if you're doing lots of serial processing, and you need to do things like maintain a consistent identity across them. Whereas here, because of how this is working, you're leaning into ephemeral compute as well, because you have the direct issuance, you don't have long-standing credentials, and so by its nature, you have to use those, short duration lifespan computes. The idle cost, as a consequence, is nice because instead of having constantly running compute or clusters that stay warm or on demand with uptime, downtime, you're looking at just $0 when idle, which made my CFO also happy with me, which was a win. And then the FedRAMP drift issue with persistent infrastructure. Configuration drifts over time. Someone changes the security group to the console. With infrastructure as code and ephemeral compute, there is no console. So all the changes go through version control, and drift is structurally impossible. We don't have interactive anything in our pipeline. So the blast radius is that fun hook. So for a data lake with 1 million objects, this IPT format here reduces the blast radius by 6 nines because you have one object out of 1 million. So just doing the fun, simple math, if you're looking at something like on the small team level, 1,000 objects and 99%, and yeah, you can do math. I was having fun. But the thing is, it's not theoretical. This is math on our production architecture. It is demonstrated. So, the way we did the setup here, Mayfly gives you that implementation, but the security doesn't come from the pip install. It comes from the architecture underneath. And the 3 things I want you to take home from this: stop rotating keys, just get rid of them. Ephemeral credentials scoped to single transactions is the best format I can think of if you want to maintain a proper practice with least privilege, because least privilege means you never trust, always verify. And if you grant a key once, that is not least privilege, no matter what best practices tell you. And then scrub before you store. Even if you're not in a highly sensitive industry, if you don't need that data actively, why the hell are you putting it at risk? Just get rid of it, hide it, hash it, do whatever. Because generators and NLPs make this really tractable at scale. It's not hard. And then finally, log the life cycle, not the data. I can't tell you how many organizations I've worked for. Like when I've contracted with hospitals, I've worked with genomic organizations, and I check the log errors, and I sit there and I go, dear Lord, this is someone's entire history. Like I found an excerpt from a VCF file, which is, a genomic record, in a log entry. It's amazing, and these things happen everywhere because, oftentimes you're dealing with people writing code who are scientists first and engineers second, which is great for the scientific advances, but it's very poor for security. And so if you can't always be the adult in the room, take that choice away from them. Just saying. So yes, log the lifecycle, not the data. Prove compliance without creating a new attack surface. And so, like I said, I built this for FedRAMP, but this works anywhere. And yeah, if this resonated with you, the fastest way to do it is to try it right here. Like I said, please give me at least until after lunch, and I'll have it up for you here. And this is specifically the AWS implementation. That's what I have right now. If you install it without the AWS brackets, you'll get the core version, which has no identity brokerage option right now because I need to do the Vault version. And I don't want to force everyone who ever uses it to install Boto, so that's why I have a forked version that has AWS. Like I said, this will be up here by the end of the day today. And play with it, have fun with it, enjoy watching, like a mayfly, the credentials will live for a day and be gone. And if you find a bug, issues tab's right there, but also, you're all Python people, we're at a conference, fix it, pull PR, let's have fun, it's Python. And so with that said, thank you guys very much. I've really, this was awesome to get to talk to you all, and open for any questions you might have.
Hello. Oh, wow, this is so loud.
Oh, yeah.
This is built for federal healthcare.
Yeah.
Have you found any consistent architecture patterns in terms of creating that audit log, in terms of what occurred, credentials created in these federal systems? Is there any consistency?
Not even a little bit. Because the problem is the federal government has a tendency, and I say this with all love and respect as a person who's worked for them, they have a tendency to hire people who meet the very specific expectations, but not with infrastructural skills in mind. They hire people who understand the casework that they're doing and who have familiarity with the internal infrastructure. And so oftentimes you'll find people will do whatever model that they're comfortable with, and there's no enforcement of standards and practice. Going from, and even within the NIH, going from NCATS to NCI, I saw massive changes in how they did their architecture. So really, that's why I tried to form a system that didn't require compliance on their side with how they build it, more just a broad framework. Yeah.
Hello. So you showed us the ingestion path. It seemed like the ingestion per transaction, there's the scoped credentials per file and stuff.
Yeah.
What about the reverse? Like when a data scientist needs to access the data in the data lake, how does that? Are those credentials?
That's a great one, and that one's actually one I've been playing with a little bit. There's a feedback going on there. So once it's in the data lake is in my model at least completely locked down as well, in the sense that no one, not even short of a break glass that requires multiple authorizations, there's no access to the objects themselves, and so they have to go through an approved terminal. Right now we're using Athena with some heavy monitoring and governance on what they can access. But I'm actually, a future state project that I'm working on is using GNN to track the trajectory of queries that are coming in to prevent re-identification attacks and things like that. But at the present level, what it is we have issuance per query, so that they can basically, every single one of them, they have to be then re-authenticated afterwards, and it happens seamlessly under the hood. But that way we can isolate behaviors and we can block them faster if something's up.
Thanks for the talk. So you say that when you have an IAM role or you generate an IAM role on a per object basis, that thing that's generating that role, wouldn't that be something that has an overprivilege, or how do you reconcile that where, for every file, something needs to actually create that role?
I mean, that's a big, yeah, that's the identity broker. Because that's one thing that we do definitely have to acknowledge, is that we've shifted the floor of trust to the identity broker. But what happens there is the broker has the ability to see that an object was created, and it triggers upon that act, and then it has the ability to issue and deliver that credential. But essentially on surface, it's doing the same limited scope that it permits. It sees something and it hands something off. It doesn't have any autonomous ability to trigger under any other circumstances because it gets the ARN from the event that triggered. And then on top of that, we have a behavioral monitoring. So if there are any unusual spikes in its issuances or behaviors aren't tracked to traffic on Airbyte, it gets cut off, of course.